Let's explore an interesting pattern in calculus, finding the nth derivative of the function y equals x to the n. Let's start with our given function. We have y equals x raised to the power n, where n is any positive integer. Let's find the first derivative. Using the power rule, we bring down the power n as a coefficient and reduce the power by 1. So our first derivative is n times x to the power n minus 1. Now let's find the second derivative. We apply the power rule again to our first derivative. We bring down the power n minus 1 and multiply it by our existing coefficient n. This gives us n times n minus 1 times x to the power n minus 2. For the third derivative, we follow the same pattern. The coefficient becomes n times n minus 1 times n minus 2, and the power of x reduces to n minus 3. Let's visualize this pattern. Notice how with each derivative, first, the power of x decreases by 1 each time, and second, we multiply by one less number each time in our coefficient. Following this pattern to the nth derivative, we can see that after taking n derivatives, the power of x becomes 0, and our coefficient becomes what we call n factorial, written as n exclamation mark. Let's look at a concrete example. If we take y equals x to the fourth power, then the first derivative is 4x cubed, the second derivative is 12x squared, the third derivative is 24x, and the fourth derivative is 24, which is 4 factorial. And thus we've proven that the nth derivative of x to the n equals n factorial,